Hi everyone. Today we're going to continue learning about our solar system. Specifically, we're going to be looking at life in space. For those of you who haven't paid attention to it yet, please notice that my email address is on the screen. You can find me at rcrawford@jcpsmail.org. If you have questions or you're having problems, that's the best way to get a hold of me. If you haven't already done so, take a moment, pause the video, and gather your materials. You'll need a pencil, your science notebook, and some color pencils. All right, let's start out with a Bellringer. So, the last time we spoke, we talked about space rocks. And so the first question for our Bellringer today is, name the two types of odd-shaped chunks of rock and metal found in our solar system. Two types of odd-shaped chunks of rock and metal found in our solar system. One of these is large and the other is small. That's the only difference between them is their size. So chunks of rock and metal, odd shaped, so we know it's not a planet. Chunks of rock and metal. Of course, we're talking about asteroids. So asteroids and meteoroids. Asteroids are the larger, while meteoroids are the smaller chunks of rock and metal. Both are potato shaped, or they're odd shaped. Let's look at our second Bellringer question. Where are most asteroids in our solar system found? Where are most of the asteroids in our solar system found? Take a moment, think about that. Of course, most of the asteroids are found in the asteroid belt, which we find between the orbits of Mars and of Jupiter. So most of those asteroids are found in between Mars and Jupiter in a relatively narrow belt. Of course, some of those asteroids might have been bumped out of there, and we call those rogue asteroids. And finally, what is the name for a chunk of ice, rock, and dust? Think of a dirty snowball. So mostly made of ice. What object, what type of object are we talking about that we find in our solar system? Of course, we're talking about a comet. So a comet. All right, so let's take a look at our objectives for today. So our objectives for today. First, I want you to be able to list the characteristics that contribute to life on Earth. In other words, what makes life on Earth possible? You need to be able to explain what habitable means, habitable, explain why liquid water is essential for life on Earth. You need to be able to describe the basic chemical composition of Earth's atmosphere. So in other words, what type of chemicals is Earth's atmosphere made from? And explain how Earth's atmosphere protects life on Earth. Finally, explain how Earth's atmosphere warms Earth. So when we talk about life in our solar system and life in space generally, the most important thing that I need you to know up front is Earth is the only place that we have evidence of life. There is no place in our solar system, not Mars, not the moon, no other place in our entire universe that we know that life exists. And so this leads to some rather interesting questions. Questions like, are we alone in the universe? Are we the only life in the universe? Is it possible that critters that we find on this third rocky planet from this sort of average star are it? And that's one of the things that we're going to be looking at. And scientists actually have a couple of different hypotheses, a couple of different ideas about is Earth our only place for life? So one group of scientists absolutely think that Earth is rare. And by that, they mean the conditions on Earth are rare. As a matter of fact, this whole idea is known as the rare Earth hypothesis. These scientists would argue that planets that have complex life like Earth, and by complex life, I mean life that is multicellular, made of more than one cell, so not single-celled organisms. So that complex life, like on Earth, are extremely rare, and that life elsewhere is extremely unlikely, especially intelligent life. And I guess we will consider ourselves to be intelligent life. So the idea that Earth is rare and the conditions on Earth are rare and that complex life therefore is rare is known as the rare Earth hypothesis. So why? Why do scientists think that Earth might be rare? Well, first off, as we look out into the solar system and then we look out even further out into the galaxy around us, and we look at stars that have other planets around them. One of the things that we have come to realize is that liquid water, though very common here on Earth, is not that common elsewhere, perhaps. So Earth has lots of liquid water. As a matter of fact, Earth's oceans, though it's salty, cover over 70% of the surface. So liquid water covers the vast majority of our planet. Sometimes when you look at a picture of our Earth from space, it looks like a marble. Most of that marble would be blue. So Earth might be rare because it has lots of liquid water. Of course, this water is continually moved. It's not just in the ocean. This water continually moves through the water cycle. It moves into all of those Earth systems that we've already talked about this year. Of course, it moves into the atmosphere, the geosphere, the cryosphere, and the biosphere. So water, we find it almost everywhere on Earth. And scientists believe that liquid water may be essential for life. It is certainly essential for the type of life that we have here on Earth. So liquid water, it turns out is important because it's really good at dissolving things. And by dissolving, I mean nothing more than if you were to take sugar and place a spoonful of sugar into a glass and stir it, the sugar would seem to disappear. That's all I mean by dissolving. So why? Why is that important? Well, liquid water allows nutrients that living things need, living cells need. It allows those things to be dissolved. Nutrients can be dissolved in water and then they can pass into cells. So cells need liquid water to survive. It allows them to move waste out of cells and to move nutrients into the cells. So liquid water, essential for life, and we have lots of it here on Earth. Another reason that scientists believe that Earth is rare is because Earth happens to be the right distance from the sun. So when Earth formed, it formed in a place that's the right distance away. We sometimes call this the habitable zone. Habitable, of course, just means able to support life. Um, so let's take a look at this idea of a habitable zone. So we have three planets here. Here we have a planet that's very close to the star. Here we have one that's a little further away, and then we have one that's very far away. Of course, in some ways, our sun, our star, acts a little like a campfire. When you're very close to it, it's very hot. When you're very far from it, it's very cold. So, if you were here on this planet that's very close to the star, it would be very hot there. We have two planets in our solar system, Mercury and Venus, that the average temperature is well over 800 degrees. Our daytime temperatures are very warm there. And so if liquid water is important, of course, at 800 and something degrees, that liquid water is going to boil away. Now, if we look at the other extreme, we'll skip this green zone here. We go out to the planets that are very far away from their star. Well, they're of course going to be too cold. So any water that would exist on a planet this far away is most likely to freeze, and it's not going to be accessible by living things. So what we end up with is the habitable zone turns out to be planets that would orbit in, or objects that would orbit in this space. It's just right. It's the right distance from the star to allow liquid water to be able to exist. And so we call this the habitable zone. Sometimes you'll hear scientists refer to the habitable zone as the Goldilocks zone. They call it the Goldilocks zone because, like Goldilocks, like in the fairy tale, Goldilocks, as she was sampling the porridge from the bears, she found that some of the porridge was too hot and some of the porridge was too cold, but some of the porridge was just right, like Earth's distance from the sun and its resulting temperature. So the Goldilocks zone and the habitable zone are really just two names for the same thing. So another condition, I guess we'll say, or something else that Earth has that makes it perhaps be rare is Earth's atmosphere. And this is one of my favorite pictures of Earth's atmosphere. So here we can see Earth's surface. We can see this is part of the atmosphere. The clouds are, of course, part of our atmosphere. But then we can also see that that atmosphere surrounds Earth and it sort of extends out into space. So the atmosphere, which I think we've talked about already this year, is really just a layer of gases that surrounds our planet. And so Earth has an atmosphere. But what is it about Earth's atmosphere that makes it special or makes it rare? So this is a good time for you to stop and think. What is it about Earth's atmosphere that would make it special or rare? I want you to pause the video, see if you can think of some things that our atmosphere provide us that would support life. Well, one of the ways that Earth's atmosphere supports life is it is breathable. So Earth's atmosphere is breathable. Okay, what exactly does that mean, breathable? Of course, Earth's atmosphere is really just the air around us, and we breathe air. But why? Why is that important? So when we look at Earth's atmosphere, its composition, the chemicals that make it up, it turns out to be mostly nitrogen. But of Earth's atmosphere, the other gas, the other chemical that is predominant in it is oxygen. And we can see that oxygen makes up about 21% of air. So oxygen, 21% of air. Of course, humans and other animals need that oxygen. When we breathe in, when we inhale, the reason we inhale is to get that oxygen, to get that chemical. We need that chemical for survival. Our lungs actually take that oxygen. It's absorbed by our bodies and then moved by our blood all throughout our body to every cell, and it helps our cells be able to break apart the food molecules, the energy that's in food. And of course, once we have that energy, we can use it for movement, we can use it for repair. But Earth's atmosphere is breathable, so having an atmosphere that contains oxygen uh, is maybe somewhat rare. 21% oxygen. Earth's atmosphere, in addition to being breathable, it also provides us with protection. So we have a particular layer, and it's shown here as being relatively thick, but it's a relatively thin layer called the ozone layer. The ozone layer help protect Earth. So some of the gases in our atmosphere, and we're talking about ozone, which is a little bit like oxygen. It's just a different type of molecule. Some of those gases can block harmful radiation, and the harmful radiation that it blocks is called UV. So UV meaning ultraviolet radiation. Ultraviolet radiation is created and generated by our sun at all times. Ultraviolet is what causes sunburns. Without Earth's atmosphere blocking, and you can see that it's blocking a big part of this UVB, without it blocking this most dangerous type of ultraviolet radiation, many things on Earth would not be able to survive. So our atmosphere does provide us some protection. It also blocks some other stuff that's coming from outer space. One of those things is cosmic rays. Cosmic rays, we don't really understand where they're coming from, but they're just energetic waves, a lot like this ultraviolet. So Earth's atmosphere, it's breathable and it provides protection. So those are two reasons that our atmosphere would be important. Earth's atmosphere also turns out to make Earth much warmer. So if we look at this picture, we can see here we have energy from the sun, comes down, strikes the surface of Earth. Of course, some of that energy bounces off of Earth, and instead of going back out into space, like we can see here, some of it actually comes in contact with some of the gases in our atmosphere, and it gets bounced right back down to Earth. And it ends up just sort of bouncing around in here, and so that heat gets trapped. I want you to think of these gases as being like a blanket. Okay, so the gases that we're talking about, they're gases like carbon dioxide. Those are called greenhouse gases, and this idea that energy from the sun, heat energy, temporarily gets trapped near Earth's surface is called the greenhouse effect. And so greenhouse gases, uh, which occur naturally, like CO2, temporarily trap some of the heat from our sun, which of course warms our planet. And if we didn't have greenhouse gases, it turns out Earth would be much too cold for life. Too much of that energy would escape back out into space, and the temperature on our planet would be below freezing, which would of course take away that liquid water. We would have a big snowball for Earth. So greenhouse gases turn out to be very helpful. They're just a natural part of our atmosphere. Now, some of you have, of course, heard or maybe even studied climate change or global warming. What the idea is with climate change or global warming is that humans can add man-made greenhouse gases like CO2 from burning fossil fuels. And so lots of power plants and vehicles put out these fossil fuels. And those get released into the atmosphere. And with more greenhouse gases, we have more of this energy being bounced around. And of course, the end result would be a change to our climate. Some of that, the longer that energy is trapped, the better our atmosphere gets at trapping it. With these man-made gases, it can cause rising global temperatures. And as you know, the evidence seems pretty clear that that's a bad thing, or maybe just too much of a good thing. So natural greenhouse effect with greenhouse gases, we need that, right? Without it, we wouldn't have liquid water. But when we have those added gases, too much. So, so those are many reasons. So if we look at our atmosphere, we look at liquid water, if we look at us being just the right distance from our star, those are some pretty good reasons why scientists would think that Earth is rare and that, maybe we are all alone out there. But then again, there are the universe is very big and very wide, and maybe we're not alone. Other scientists would say that Earth is not that unique. They think that with the billions and billions and trillions of stars that are in our universe, and many of those have planets around them, that mathematically it's just impossible that we would be the only life, that only life here exists. And of course, no matter if you happen to agree with the rare Earth scientists who say Earth is rare and only life is here, or maybe you do think that there is life elsewhere, chances are that's not a question that we're going to have an answer to anytime soon. So um, do want to take a moment, and we're making a change on the way that we get some notes into your notebook. And so these are the notes that I actually want you to copy in. So for this particular video, these are some things that I want you to copy into your notebook, and I want you to copy these notes exactly. Underline, and if there's underlining, I want you to include that. And so it turns out to be a lot of times like a term, but then with that term, there's also sort of a definition. Some of these are not vocabulary words. Some of these are just meant to help you on these quizzes as they come up. And of course, you will need these for the quizzes. So if you will, go ahead, pause the video, and copy these notes. When you finish with that, you are completely done. And so for now, I think that will do it. Until next time, stay curious.